This conference will now be recorded.
Good morning and good evening, folks. Before we jump into the HLD review, two things I want to highlight. One thing is the 2022-05 release. The branch is not created yet. Team is still working on it. That's the first one. The second one is the 2022-11 release. Currently, we are calling for the features for the 2022-11. So if you have any features want to contribute, please check the Google groups and reply the message. So we are still have some time to collect the candidate list, feature list. That's the two things I want to remind the community. In today's meeting, we will review two HLD. The goal is to review two HLDs if we have enough time. Those comes from the NVIDIA. The first one is the systemd boot chart integration. I think the presenter should be Stephen. Let me make you the presenter.
Hi, can you hear me?
Yes. Now you are the presenter. Please go ahead.
Okay. Sure. Can you see my screen?
Yes.
Okay, so I'll start. I'm going to present an HLD about Sonic integration of systemd boot chart into Sonic. So what's the motivation? Sonic is a highly modular and composable system where every new feature is often implemented as a new script, new utility, daemon, or Docker container. And a lot of these components start together at Sonic boot. When those components start together, they create a lot on the CPU, and the boot time is increasing. Now, what we want to do is to integrate a tool called systemd boot chart, which is a sampler-based profiler into Sonic, so that we can analyze the boot sequence, how many time each component took, how much CPU it took for component to boot. So based on that, we can analyze where is the bottleneck, which components are loading the CPU, which scripts, etc. Just to give some background, so in the past, we have used systemd boot chart already twice to find a degradation in boot performance on warm boot. And two times we found that some Python scripts, some short-living Python scripts that are called very often on boot, in total cause a lot of CPU load. So the first time it was, as far as I remember, the Sonic config gen, and there were optimizations for that. And now we found out that a tool, a Sonic DB CLI tool, is called very often, like hundred of times at boot, and it's causing a lot of CPU load. So this tool helps to analyze and find issues like that, and to see which components took a lot of CPU and at boot. Here you can see the example plot I pasted here. Uh, this plot is very big. It is an SVG image. So if you open, you can open it in a browser and increase the size. And every line represents a process here. And at the top we have a short summary of topmost CPU consumers. Let me try to open that. Yeah, for example, here. So let me go to the actual design. So we want to integrate this tool with Sonic OS. We want Sonic systemd boot chart to be installed in the system by default. The feature itself is disabled, meaning there will be no sampling at boot, and it is going to be enabled via CLI. So we need a CLI tool to interact with systemd boot chart. We need to enable, disable. We need to configure how many samples and with what frequency to collect, and display systemd boot chart configuration and the path of generated SVG plots. So adding it to the build system is simple. We also include a build time flag in the build system, include boot chart that we would like to set to yes by default, since the package itself does not take much space. And provide a default configuration for the boot chart. So this is the default configuration, which means that it will collect samples for 3 minutes since boot with a frequency of 25 samples per second. And we want also to add a CLI utility called Sonic Boot Chart. This is a standalone utility, just like we have for KDAM and Sonic installer, not related to the config CLI tree. So here are the commands that we are going to implement. We have config, disable, enable, and show. So to enable Sonic Boot Chart, it just enables the service to start at boot, and disable means we just do system control disable. Also, this tool, when it detects that the systemd boot chart is not installed, meaning we build Sonic image without it, it will tell a message that systemd boot chart is not installed. Configuration. So you can see the configuration example where we are able to configure how much samples and what is the frequency to collect samples. So what this command will do, it will just update the etc systemd boot chart conf file, and the next time boot chart will run, so after you do config, you have enabled boot chart, and after you do reboot, it will take these new values. And once you have rebooted and the service, the systemd boot chart service finished, meaning it finished collecting samples, you will see similar output in the show command. So here in the show we have few fields. A field called status displays the configuration status, whether it's enabled or disabled. Operational status, meaning whether it's currently active, whether it's currently collecting samples, or whether it finished collecting samples. Also the configuration, the samples and frequency. Time, which is just a result of division, and just for user to understand easier how much time it will collect samples since boot. And once it finished, in the output will appear a file with auto-generated name based on the date it was generated. And the directory for output files is by default it's run log. it is a systemd boot chart default, which is a good choice to be a default because runlog is a temporary folder, meaning after reboot it is flushed. So we will not, in case we have enabled it and not disabled it, and after a few reboots, it will not take space. Yeah, because those SVG plots are actually um, pretty they are pretty big. Yeah, here's the description of each field. And the usage example, you first need to have the boot chart enabled in your included in your Sonic image. You do enable it. You perform some kind of reboot, and after reboot, wait till system reboots and the plot is generating. You can see it by querying the show of this utility. That's basically it. So it's a pretty simple feature when installing a Debian package called systemd boot chart and having like a wrapper, CLI wrapper to interact with it.
Questions.
Hey, yeah, go
Go
ahead.
ahead.
Yeah.
Adam,
Oh,
go
yeah.
ahead.
So I think it's a very useful tool. So thanks for this. And I'm just curious, can this be a generalized tools to, because bottom line is that if you are starting your measurement from the boot time, I'm curious if this is something can be enabled in such a way that, let's say I'm gonna measure a convergence. Would this be something that I can collect data for how much CPU time is being taken for each module, or how much
You
time
mean
the
after
script
boot?
is being used? Yeah, exactly.
Yes, the systemd boot chart it supports such a way of using it. However, we haven't yet planned to implement a CLI to like wrap such a usage. But since it is installed in the system, you can just start the systemd boot chart binary, which will be installed, and in the runtime after boot, and it will basically do the same.
Right.
So we could implement a wrapper, a special command in our wrapper. However, we haven't yet planned this, but you can do that with the systemd boot chart directly.
Okay, thanks.
Yeah, I actually have the same question here. So if I want to use it that way, without, rebooting it, so as soon as I enable and started it, right, then it will start capturing what's going on currently based on the
Mhm.
sample rate, right?
Yes,
Okay, and
based
then
on
it
the
will,
how many samples you have configured, it will start from the moment you started it till it collects this amount of samples.
okay, and then if I want to take a look at it, then do I have to disable it
Uh,
first?
when you do this in runtime, you will run it as a binary, right, from the shell, and once it finished, it will just stop, and you will see the process has stopped. And after
Oh,
that, you can look at the directory run log or execute this command. I'm pretty sure this command will also like display, because it just displays the content of this directory. So you will see that in this command.
I see. So the configuration on samples will just keep sampling up to that number and then it'll stop basically. So you
Yes.
control the samples. Okay, got it. The other thing is you mentioned you configure this and then you reboot. Do you have to save the configuration? Config save? No, this is separate.
No, this is completely separate. So our wrapper is just a wrapper around a systemd bootchart and its config file, and it's just saving immediately when you do config samples. It saves it to etc systemd bootchart file. Yeah, and so there is no involving here of config.db database, so you don't need to do config save for this to be permanent. It's like by default permanent because of the
Okay.
way how it works. Yeah.
Okay. Any guidelines on the memory availability when we turn this on? How much it's going to cost, or the amount of disk space that's needed?
So one if when you have this tool installed, it takes like 128 kilobytes more. Um,
Runtime.
when
Yeah.
it's just the installed size. The SVGs are like 10 megabytes, maybe something like that. Um, so it's pretty small. And the RAM usage, I haven't done any measurements.
Okay. Because I'm for some system, if it's already like running low on resources, enabling this might just crash it, right?
Yes, and as any like sampling based profilers, it causes it by itself it causes a lot of CPU load. So as you can see from this example plot, we can see that the systemd bootchart itself is a top CPU consumer. However, we can see it's not interesting to look at this. It's of course the systemd bootchart because it collects the samples frequently. However, we can see all the others. So that's interesting.
Okay.
Hey,
Yeah. Thank
Stefan,
you.
this is Madhu. I have two questions. So one question is it the system boot chart covers Dockers too? So it's going to analyze for Dockers too.
Yes, so if I will, for example, search for work agent, I will see when it started. See, so every processes inside Dockers are also displayed here.
Okay. So the follow-up question I have is like, how do I know whether this feature is enabled on the Sonic device? So is it part of a feature list? Do we have a CLI command whether it's already enabled or disabled?
It is not on the feature list because the feature in Sonic terms, a feature means a Docker container, and
Right.
this is just
Right.
a simple like systemd service. You can do sudo sonic bootchart and any command, for example, sonic bootchart show, and if it's not installed, then it will this command will exit with non-zero exit status and print the message that it's not installed.
Yeah, so the question I had is like, I mean, I'm not sure. Like, I mean, let's say I started this boot chart and I forgot to. I mean, I want to know like who is consuming more CPU and memory, right? So I understand that if you have some a utility saying that what are the features enabled, so that we can go and turn off and kind of debuggability stuff. So I mean, right now I think this is the only way we know whether it is enabled or not, right?
Yeah, yeah.
Or do we have any utility that how many features and I mean features are like tools enabled as part of compile time, like yes or no thing?
Mm, I don't
Okay.
know, but I have thought about. I'm not sure if we include like compilation flags as part of image metadata. It would be useful to see with which flags it was built, this image, and then you can use that if that's available to see if the image was built with this flag or not.
Okay. Okay. Thanks,
But
Stefan.
I'm not sure that's currently implemented. Like we don't save the flags, although it would be useful, I guess. We don't save
Okay.
the flags with which this image was built.
Okay. Yeah. Thank you, Stefan. Yeah, we can do that. Yeah.
In order to see that chart, the graphic thing, do you have to offload this file out, and then how do you
Yes.
display it?
Yes, it's an SVG. So you just copy it on whatever host that you can open it, for example, in uh, browser, as I did. So yeah, but you first need to copy it from the switch.
Is it possible to have a command at some point that says start collection and stop collection? That would be very useful.
Yeah, that's what we talked about with the how to generate such plots at runtime if you're not interested at boot, but in
Mhm.
runtime when some, let's say, some workload is done. Um, you can do that with this, by directly using systemd boot chart. It's
Right,
possible. However, we haven't planned for such commands as
right.
you. Yeah,
Yeah,
but it's certainly
pretty much. Yeah.
possible to implement. We could start this, let's say we could start the systemd boot chart with, I don't know, a lot of samples, a lot of samples, and then maybe sick term it when you do stop. I don't know.
Hmm.
For example,
Hmm. Yeah,
yeah.
something like that. Something more easier using a CLI would be good at some point. Thanks.
Yeah, that's definitely doable. Just we haven't yet time
Stefan?
and plan to implement it. Yeah.
Actually, I think there's a lot of value if
Yeah,
we
but just
if
a
it is
moment.
something that you can generalize this as a general like profiling tools instead of just the boot time. Again, I mean something if you feel that is something that that you can contribute, I think a lot of you'll benefit a lot to the community.
I have a suggestion, if you don't mind. Since this HLD is for what is going to be, let's say, available as soon as it can be merged, then the next level is whoever wants to add another CLI will be able to do it on top of the existing infrastructure with the build and so on. I do suggest, Stepan, since there was a question how to do that, just add another like appendix or something at the end of the documents how to run it on runtime, regardless of the
Mhm.
CLI. Okay, so if someone wants to be guided how to enable that from one point to another point, just explain how it works or refer it to a place where this is documented, okay, because this is like a
Mhm.
generic tool, it's not like a tool that you invented. And if anyone would like to add another CLI later on, he can do that, okay? But let's educate or refer to where this information can be shared.
Sure.
So
Sure.
Stefan,
I
one
will add it.
question on the image upgrade. If I enable this feature boot chart and then I do the image upgrade, um, on the newer image, this boot chart will be enabled by default or it's not handled yet?
It's not handled. So
Mhm.
usually when you're performing like a test and you want to see the boot performance of a certain image, there is no point like you can upgrade to that new image, like run it, and then from that running image perform a reboot. I don't see a point to measure to like implement such a configuration migration.
So I want to know the boot chart of the newer image, right?
Yeah, but you can reboot to a newer image, enable it
And
there, and then reboot.
yeah, that the extra reboot is what I'm trying to avoid. Okay. Anyways, that's
I,
an option right now, right?
yeah, but I don't really know if that's um, if that's worth to do, because I don't see a difference whether you boot from old one or from the same. There should be no difference.
Yeah, I'm just trying to carry over the configuration from old image to newer image. Right? That's an thing basically. I don't
Yeah,
want to do extra configuration.
this is like a tool mostly for developers, right? If you want to debug a performance issue. So I guess the developer can just install the image with an issue and do a test with it without
Yeah.
thinking about an upgrade path, how to handle it. Yeah.
Okay.
Stefan, one more question on the same lines, right? Is there a way to enable it during the build time itself? Because let's assume there is a flow to install from ONI versus say doing an upgrade. Both flows have different kind of, there will be minor changes in the boot mechanisms. For example, if I install through ONI, there will be something else done differently. So, is there a way to handle that use case?
It's certainly possible, since we can add a line we can add a build flag, right? Whether it's enabled by default or not, when the system starts. And depending on that build flag, it can, in the Sonic Debian extension script, it can call the Sonic boot chart enable script.
Mhm.
We can certainly do that.
Okay, thanks.
Okay, thank you, Stephen. So if no more
Sorry,
questions,
I have a question. Hey, Stephen. So
Mhm.
is this collection before init ramfs, after init ramfs?
I think it's after.
So there's a
Because
chance that we could pass in a kernel parameter
yes,
to
it's
generate the configuration method in ramfs stage.
yes, it's possible. Systemd boot chart supports this. Passing itself like instead of init, and then
Yeah,
it starts collecting it very early.
yeah, I don't know if boot chart can support that or not, but I think we can inject a code at init ramf stage to generate the configuration file, right?
Yeah, but we need them to start it. I don't know
Also enable
if
the
that
okay.
stage, if at that stage systemd is even accepting like starting.
No, you don't have to
services.
start, right? So if you generate a configuration file, would system D when starting later, it will pick up the configuration file and do the sampling.
And how it's different when the configuration file is when it's enabled prior to reboot, like not from init ramfs.
Yeah, consider a
Stage.
scenario that we always repeating, or you want to investigate into an issue from image A to image B. You don't want to recompile image B, you might lose the repro. Because you need to recompile image B to make this by default enabled and put the configuration file there, so that image B can pick up the configuration, right? So. But if we add the support in the init ramf, then image B, as long as has this boot chart compiled in, then it can self-generate this configuration file and start collecting during the boot up time.
Yeah, that looks like you want to migrate the configuration from images between images when doing
So basically,
upgrade.
one way to enable the data collecting for the next image without having to touch the next image.
Yeah, that's also doable, although you know that will take some extra efforts to implement that.
So
As
let's
the
let's try to let's the scope of the feature. I'm sure that we can do much more. So one thing is that what we want to add another in the build time, whether we want to enable it or not. Okay, it's not just include, but also enable. And this is the scope that I think that we can say that this is for sure what something that we want. Like, and later on, if we want to extend and have like with the Sonic installer, whether to migrate this file or not, this is another flow, which is, I think it's more complicated in terms of changing the way that Sonic right now it works, because for now Sonic installer is not like taking files that are changed from one system to another, like if they are like modified into the without a config DB. And this is the one that we don't have it in config DB. I don't think that we should. So let's put it like a comment, which is will be considered later on, which should not block this feature. But we can talk about like if you want to add another step, another phase on the document, which is not the very first one, we can do that. So whether we will do that or anyone else we would like to do that, that's not a problem.
Certainly, this feature can definitely go and we can add other PRs on top, but it would be good to capture all these comments from today as a future roadmap or something within the document at the very end. And it could be anyone who could pick that up, and at least we'll have one place to look at what are the comments and work on that in the future.
Sure. I will summarize the comments, the suggestions at the end. So we will have a place where it's all recorded.
Hey, Stefan, I mean, during the integration of this tool, did any process catch your attention with this, or like what was the real motivation?
Yes, we had a problem like on recent branch with Sonic DB CLI, which is a short-living tool. It's like it's a wrapper around Redis, like CLI, but it's written in Python. It's not very optimal, and it causes a lot of load on the CPU when called a lot of times. And at boot, this utility is called like hundreds of times. Like every service script, every other scripts are calling that tool, the Sonic DB CLI, and it caused a problem.
Okay, I think we sorry, go ahead. One last question. Yeah, I think we should move on. Yeah.
So after flagging a particular process or a process which is causing an issues, the mitigation is up to the individual developer how to go about it. Right? It just this tool only gives you which is the which is the problematic process or flow.
Yeah, which is a problematic process, which takes a lot of time, or whether you have like congestion between two processes fighting for CPU resources, especially on the systems with low amount of cores. That kind of problems we can see from that plot.
Yeah, my only concern here is not a concern, just a comment. There are a lot of useful tools like this available in the community, in the Linux community as well. Like making it part of a Sonic build image. I mean, there is no end, right? Like if I find a useful tool later, I'll go and make it part of Sonic build image. That would cause the image to grow, but but as a standalone tool, right? I can always get this tool installed on my Sonic system and do whatever I can do as a developer, and then get rid of it, right? So what I'm trying to say is that there is an effort to integrate this tool. Instead, we can as well pull any time from the community as a binary and just install and be done with it, and don't need to install in part of the Sonic image.
So yeah, I will explain. So we plan to have it integrated also in our tests as well when we run, for example, warm reboot test and we want to generate a plot for it. So and we decided that we would like to have it integrated into Sonic. So then the test is doing basically the same. It's just doing CLI commands on the Sonic without like installing some packages, configuring files, making sure it will work. Also, it's easier for the developers when you have a wrapper with a nicer output. Then, like every time, read the documentation for the tool and understand where are those files that are configuration files for this tool located and such things.
Stephen, I agree with Paniraj's point. I think being this tool, used only for the runtime would make more sense than integrated as part of the tool image. So, I mean, there is, because you are saying it's developer tool, and developer can, all we need is like the internals we don't need to worry about. You can provide a wrapper as and when we need to look at the boot chart, the developer can, runtime execute the tool, the internal mappings of the kernel settings, system settings, all these things you can do. And then once the developer restart the system, then we'll get the image, right? So I don't really understand why it needs to be part of the image.
Yeah, that's why we have like a flag. You can control that.
Yeah, I mean, flag, having a flag
Venkat,
means you have the code.
And if you have it disabled,
just a moment, John. One point
yeah,
I want
go
to
ahead.
disagree here is it's saying this tool is just for the developers alone, right? There can be testing, DevOps, etc., who are using the Sonic, and they don't kind of have the exact skill set as maybe developer to kind of enable it and have to go around. So this simplifies a lot of things. We have a documentation, and then we can enable it easily and then provide the input. Let's assume something happens in the production or say some other testing environment. They could enable it and give the input, and it greatly reduces the amount of time that needs to collaborate. So I think this still is really helpful in that way.
In production environment, I don't think it is useful yet.
Of course, it can be funny. Let's assume that there is a production setup where the device boot up time is increased, which increases the traffic. So in that case, we can isolate the device and then try to reboot and figure out what is taking much time. So of course, there are use cases where it can be used in the production.
So you need to test it. For this tool to be enabled, you need to enable and reboot it, right? So
correct.
It's not like an on-demand.
Yeah, you have to enable and reboot it. There can be ways which it can be done.
So then that is not a production use case. So
no, that's what I say. You can isolate the device and try to recreate the issue.
Everyone can decide whether to build it with this flag or not. This is like eventually what is the end user decide whether his image will be built on with that or not. We are not changing the build for anyone. Like Sonic does not compile and provide it to production. Each end user decide, or each let's say the one who decide to use Sonic will have all the ability to integrate the tool, whether it's for debug, whether it's for the development time, or to debug a production issue. So at that point, what if the tool is included in the image, you can use whatever is mentioned here through the reboot, or you will be able to use based on a guideline that will be shared in the document.
So folks, I think the comments has been collected, right? In terms of the standalone tools versus integrated tools, I think offline we can have more discussion by leaving comments on this HLD or with some email thread. That should be fine. I think we have a lot of the discussion and also the good questions. I think that's cool. Personally, I think this is a good profiling tools to help us to identify the potential performance issues and also the especially during the bootstrap time. I think it's a good option, but yeah, I think we can have more discussion offline. We still have another HLD to review in today's meeting. I think we need to switch to that one. So it's the syslog source IP config in the UDP protocol. So who will be the presenter?
Okay, thanks. I will stop sharing. Thanks for all the comments.
Yeah, I think that's a good.
Hi, it's me. The next. It's Nazari. Yeah.
Okay. Yeah, I think you can go ahead, share your screen. Hey, Nadari.
I'm here.
Okay.
Yeah, sure. Just a second. I'm searching the window. Yes. Okay. Trying to share. Please tell me when you will be able to see it.
Yeah, go ahead. Yes, great.
Okay, cool. So Sonic syslog source IP configuration. Basically, it's also a small feature. It's an extension to the existing remote syslog logging, which is implemented based on the rsyslog-d in Sonic. And basically, the idea here is to allow user to do a source IP mangling, and that might be useful for security reasons. And also, the plan here is to add a support for the remote port configuration and for the BRF support as well. As part of this design, we are focusing only on source IP mangling for UDP protocol. So the TCP protocol is out of scope. And the list of the requirements is, as I mentioned before. So it's source IP address configuration, a remote server UDP port configuration, and BRF device support if needed. So the command interface, as part of this feature, we will extend the syslog configuration CLI group with a set of options to add these parameters. And also we are going to add a new section for show to query the existing remote syslog logging configuration, which is today is missing. Yeah, so that's basically a plan. Regarding the design itself, so basically here we would like to reuse the syslog on message forwarding module. It's an built module in the rsyslog-d. It's available starting from the version 8, and basically it provides all the necessary capabilities which we would like to reuse. As you can see on in this table, this is what the forwarding module provides. Basically, we can configure the target. It's the destination IP of the service. It can be either IPv4 or IPv6. Also, we have the address field, which can be used for source IP configuration. And we have the port, which is basically stands for the remote port configuration. The protocol will be always like UDP. And the device basically can be used for BRF configuration. Yeah, so also as part of this feature, we would like to use only the existing IP addresses, which is basically are present in the Linux. We don't have a reference to any stuff from the config.db, It's just the IP configuration. Yeah. And the second thing, it's a configuration agent, and the configuration agent is basically composed with the rsyslog and the rsyslog config services. So the idea here is that the rsyslog config is basically reads the config DB and then uses the Sony config GAN tool to generate the rsyslog D configuration file from the template, and then basically restarts the rsyslog D service itself. So this is how the things work. And this is what we have from the config DB point of view. Basically, we have the rsyslog D configuration parameters and the config DB schema. So this is how it looks like. For the syslog server key, which is basically stands for IPv4, IPv6 address we will use for the target, it's the destination. For the key source parameter will be mapped to the rsyslog D address, port will be the port, and the VRF will be mapped to the device. Yeah. One thing here also, basically, as I mentioned before, the idea is to use only the existing IP addresses in the system. There is an ability called IP-free bind. This is the feature which offers the rsyslog D, which allows user basically to bind to an existing IP address in the system. But originally we decided not to proceed with this way, but rather to stick to some existing stuff in the Linux kernel. Yeah. Okay, so basically we have the main two options here. It's source IP configuration and the device configuration, which stands for VRF support. And basically, the different combination of these options may require a different business logic to handle all the possible scenarios. So here we will go like step by step and check all the options. The VRF and the source options, as well as the port, are optional, so they are not mandatory. And basically, that means that the existing DB schema and the configuration approach is fully backward compatible. So there is like no need to do any DB migration comparing to the previous versions. Yes, so let's consider the first use case when, for example, VRF and source are not provided. So basically, in that case, the Linux will automatically pick up the source IP address based on the destination and the routing table, and will use the default VRF. And this is the example of the rsyslog D configuration, which will be eventually generated by the rsyslog config service. And the second thing, it's when the VRF is not provided, but the source IP address is set by user. So in that case, we need to check whether the source IP is configured on any default VRF member in the Linux. If yes, we can configure it. If no, the error will be generated. And here we have the example of the configuration for this use case. So basically, the keyword address is present. The second thing is basically when we have the VRF configured, but the source IP is not provided. So in this case, first we need to check the VRF type, whether it's default, management, or data. For the data VRF here, I'm referencing to the VRF table in the Sony config. So the default, in case of the default VRF, we will skip VRF configuration. So no need to generate the proper line with the device keyword. It will be like the rsyslog D defaults. In case of the management VRF, we need to check whether the feature is enabled or not. If yes, so we can safely proceed with the VRF configuration. And if it's no, we will generate an error. And for the data VRF, we need to check whether the VRF is a member of the Sonic VRF table. If yes, so we can proceed with the configuration, and if it's not, so just to generate the errors. And here we have the configuration samples for all three cases. So the default VRF, the management VRF, and the data VRF. So the management device name is basically reserved for the management VRF feature. And for the data VRF, we have this notation like VRF prefix minus and actually the device name. And the last thing, when we have both VRF and source configured, so also we're checking the VRF type. Then based on the VRF type, we are checking whether the source IP is configured on any default VRF member for the first use case. In case of the management VRF, we're checking whether it exists inside the management VRF. And in case of the data VRF, the same check. Yeah. And also, we have some examples for the configured config file for the rsyslog. Here, as you can see, we have both like address and the device keywords to be present. Any questions so far, folks? Or we can continue with the DB schema and the CLI.
So, Nazari, one quick question on the source IP selection, right? So, other system services in Sonic today uses source interface for whatever the purpose, right? That we are trying to solve. The NTP, TACAX, and multiple other services are using the source interface. Why can't we, for the consistency reasons, so can we use the source interface as well for the rsyslog instead of the IP address?
Yeah, originally we were considering such an approach, but it has some downsides. One of the things is that here we are talking about source IP address configuration, and because the interface can have multiple IP addresses configured on top of it, right, it's not clear which IP address should be used by the default. Here the user has like a fine tuning for that purpose. And also because one of the requirements to support the VRF, so it's kind of complicated to have both like a source interface in the configuration and also the VRF device as well. So it was decided to have like configuration as simple as possible and to stick with the source IP. Also, it has like a direct mapping between what is configured in Sonic and what we have in the rsyslog, which basically provides. So that's basically the motivation here.
Yeah, so which means like the same problem that you stated is present for other system services as well.
Correct, correct. Also, having a source device, let's assume that we would like to have a source device configuration. So it adds a lot of complexity in terms that there can be different types of the devices in the Linux, like the tunnel devices, VRF devices, and so on. So that requires.
Okay, I'm trying to see like this OM FWD as the support to include the source interface rather than IP address. So internally the tool will select, when it comes to IPv6, let's say link local, global address, and all those things, it will select the appropriate, the deterministically it will select the IP address or something like that. I don't know. I think that should be an thing that you cannot randomly choose the IP address, right? There should be a way in which it chooses the IP address in the backend, right? So that's how we can.
Yeah. Yes, you're totally right. So again, that's the main motivation here. So in case if user explicitly specify what he wants to use as the source IP address, it's more clear. And simple.
Okay, yeah.
Sorry, one question. So will this one IPv4 specific, or is it also supported IPv6?
Yeah, it also supports IPv6. So here for simplicity, I have only provided the configuration samples with the IPv4. But
Okay.
yes, we do support the IPv6 as part of this feature, so no issues with that.
Sorry, one question. When a user
Yes,
changes the configuration to go from default VIF into the management VIF, internally, do you restart the search log D?
No, actually, we will talk about this a bit later when we'll proceed with the end model. So in end model, we have a reference to the VRF table in Sonic. So there will be a check implemented as part of this feature. So in case the management VRF is enabled and user wants suddenly to disable it, but the syslog configuration exists, so there will be like a warning message. So the VRF management can be disabled before the relevant configuration is removed in the syslog D. So that basically.
So that means you require user intervention explicitly.
Yes.
Get it, got it. Thank you.
This is like a Linux philosophy, so we don't do anything without the user intervention. So there should be a prompt, and then the user is the decision maker here. Yeah.
Got it. Thanks.
I had a question. So today, like when Sonic boots up and database container comes up, those log messages are also sent to the syslog server. So in this case, when you have configuration and the database itself is still coming up, what happens in that case? Because the target IP or the address is not populated yet in the config DB. So what will happen then? Will the logs be lost?
Actually, this is how it works today in Sonic. So we don't change the original design. So until the service is started.
Right, but in Sonic, when the rsyslog restarts, there is no dependency on any configuration today, right? There is no additional, like we don't do any config DB lookup.
Yes, correct. So and today this feature is basically disabled by default. So there is no like a remote login.
Correct. So that's what my question was. Like, sorry to interrupt. So let's say we have this feature configured, right? But before this configuration is applied to config DB, there will be logs already generated by database initialization, right? So what will happen in those logs? So what will happen to those logs? Like, will they be sent with a different source IP address?
Actually, okay. So basically, it depends on the service init flow. As far as I know, the rsyslog D starts before the database, and in that case, when we are trying to reach the database, yes, so probably some portion of the messages will be lost.
Sorry, but if rsyslog D starts before database, then all your DB lookup will fail, right?
No,
because the syslog server.
The database, no, after the database, we have all the information available. So the rsyslog config service will be able to get to the database and to query the data and regenerate the config file. It's like one-shot service, and it starts only once on the system boot, and that's it.
Okay, yeah, no, I get that part, but I'm just I wanted to know when rsyslog restarts, is the assumption that all the syslog server is already there in config DB and and the DB is already populated? Because there is like a timing thing here, right? Which one comes first? If rsyslog D starts first and database is still loading, then all the lookup to do the server configuration will fail.
No. It's again, it's how the things works today in Sonic. So today we don't have such an issue. So basically, everything is configured properly, and we don't have the race between the database and the rsyslog D itself. So
correct, sorry, but today we don't do any config.db lookup when we do rsyslog init. Is that correct?
No,
there is no dependent.
No, we do, because there is a rsyslog config service which uses the same approach, and it reads the database and generates the rsyslog config file.
Okay, I'll take a look and comment on the document offline.
Okay. Okay, let's go quickly through the rest of the document. Basically, here we have the DB schema in the ADNF notation. So it's a standard approach, and you can take a look later on that. So I will continue with the examples. So the data samples, this is how it looks like in the config.db with the Redis CLI. Here, as you can see, we have an examples for IPv6 configuration and IPv4 configuration with the three different types of the VRFs, like the default, management, and the VRF data. This is how the configuration looks like from the JSON point of view. Basically, the same. Today in Sonic we have an empty dictionary, and with this new feature we will add these options. So. And because each of it is optional, so it's fully backward compatible with the previous like Sonic implementation. So for configuration migration, we don't need any special handling. And this is how the flows looks like. Basically, these diagrams for adding and removal process is the same what we have in Sonic today. The idea here was just to simply update the config generator to support these new options. So the entire flow looks the same. So first we have some processing in the CLI, like preliminary data validation. Then we adding the syslog server configuration to the database, and then doing the restart of the rsyslog config service, which basically generates the rsyslog config file while reading the config.db contents. Why it was done like that? Because the rsyslog itself doesn't support the incremental update, and the only way to apply the new changes is to basically restart the entire service. So this is why it was done like that. And the final step here, as you can see, the rsyslog config service basically restarts the rsyslog and it loads the new configuration. So this is for configuration adding flow, and for removing flow, basically we do the same. The only difference that we were removing the configuration from the database and then doing basically the same restart in the service, and that's it. And the CLI. So basically, we are going to extend here the config syslog add section with the three new options. It's a source for source IP. It can be either IPv4 or IPv6 with the server UDP port and with the VRF device support. And this is the usage examples. So basically, how you can add a new syslog server. It's a destination IP and the set of the options, and also how to remove the configuration. And this is basically the show section. So here we have a couple of servers configured with the source IP address, port, and the VRF devices. Any questions regarding the CLI so far? Okay, let's end up with the Yang model. So today we have in Sonic we have the Sonic syslog Yang model, and basically the idea here is to extend it a little bit. So basically I'm adding here the source, port, and the VRF leaves. And for VRF, the interesting thing that there will be a type union for both like a default VRF type and for VRF name from the Sonic VRF table. Yeah, that's it. So basically, there will be a validation for two special keywords like a default and management, and also a ref validation for the VRFs from the Sonic VRF table. And that's it.
Okay, thank you. So we are running out of the time. So anyone has any question? Maybe one last question. Otherwise, we can use the comments on this HLD to sync up. Okay, thank you, folks. See you next week.
Thank you, guys. Have a great day, and bye-bye.